Okay, now let's talk about the second situation that you can encounter when dealing with substitution method. And I'm trying to go in order of what I think you're going to encounter. So this one I think is going to come up on a fairly regular basis because in science and technology, fractions are pretty prevalent. However, so right here, this is a number divided by a letter squared, and that occurs a lot when you're dealing with functions involving distance because Pythagorean theorem is a square. So especially things involving circular motion or radial forces, you're going to end up with letters on the bottom. And there is a very clever workaround. We did briefly talk about this a little bit last week in one of our classes, but if you've got something on the bottom, there is a law of exponents that allows you to move that to the top. So you can move that to the top, and all that happens when you do that is the exponent changes signs. Okay, that's all that happens. Exponent changes sign. So a negative exponent would become positive, a positive becomes negative, and now you're off to the races because now that's just power rule. I'm going to add 1 to my exponent, so that'll be x to the negative 1. Let's not forget my plus c. And I'm going to divide by my new exponent. So divide by negative 1, so that is negative 7x to the negative 1 plus c. Move that back to the bottom, negative 7 over x plus c. So I have found my antiderivative or my integral, and I did not have to use substitution method. And that's great. However, if we look over here, now the bottom is no longer as nice and simple. If I move this whole thing to the top now, things are going to get a lot more complicated. Okay, so now we have to come up with a new rule. Okay, and that is how to deal with fractions. Now this one is a little trickier because it's not always set in stone. So I'm going to give you the rule that works the majority of the time, and let's look through the examples real fast. Yes, I'm going to give you the rule that works the majority of the time, and then I'm going to talk to you about the exception. Okay. Okay, so typically, if you've got just a regular fraction, no exponent situation, you're going to get rid of the entire bottom of the fraction. Okay, so right here, I'm going to let this entire denominator be removed. Okay, so that's a horrible looking 5x plus 3. Here we go, 5x plus 3. All right, so now that is completely gone. I'll do my same du equals 5 dx. That stuff, this whole part right here does not change. Once you know what to let u be equal to, substitution method is easy as can be. It's just rinse, repeat, and I mean, it's very, very straightforward. You have to know what to let the u be equal to, though. So that's the part that's the trick. I've just got decades worth of practice now. Oh my gosh, decades. Whew. Man, I'm getting old. Okay, so now that I've got all of that done, now I can move up here and start plugging it in. So that's going to be the integral of 7 over u times, that is one thing I dislike about this tablet. 1 over 5 du. Okay, I may be looking here not too much longer about getting a newer tablet. This one is 4 or 5 years old, and I bought it at a discount, just trying to see if it would be good for taking notes. I didn't want to go all in on an iPad Pro or something like that unless I knew that it would be successful. Now that I know how it works, I may do something like that. All right, so here we go. We are to here. Now, I do want to remind you guys about a rule for integration. 1 over a letter, regardless of the letter, is equal to ln of that letter. So if it's 1 over L, then that's just going to be ln of L. Okay? So this is going to be 7/5 times ln of U plus C. Boom. That is a very important rule because 1 over a letter happens a lot, a whole lot. So now that's just going to be 7/5 ln of 5x plus 3 plus C. And I'm completely gone. All right. Any questions about that one? Any questions at all? Okay. Now, I'm going to go ahead and skip the next one for a reason. I'm going to work the next couple because there is one exception to this whole let the entire bottom be your U. And that exception is this one. So I'm going to hold off on that one and work it last. I should really rearrange the order of these. So I'm going to work that one last to get a few more examples of this in, and then I'll come back and work the exception. Okay. So right here, I want to let the entire bottom of the fraction be my letter U. And so U is going to be equal to x squared minus 6. So that means that du is going to be equal to 2x dx. Move this to the other side, and I'm going to get 1 over 2x du is equal to dx. So now I am good to go. I've done my substitution. I've got that all ready to go. And so now I'm ready for the integral of 10x over u times 1 over 2x du. Okay. Now notice how I'm going to always end up with 1 over u. That is a very important integral to know because 1 over u, or 1 over a letter, comes up a lot. Okay. So that's 10x over 2x times 1 over u du. So this is 5 times ln of u plus c. Replace back in my x squared minus 6, and I am done. Now let's clean up that 6 a little bit. And here is my final answer. Any questions about this one? Any questions at all? Once you get the hang of substitution method, you're like, oh, this is no big deal. It's not that bad. Okay. I'm not saying you want to look forward to it. I'm not saying I wouldn't rather be watching Netflix right now or playing a video game or doing almost anything else other than math, like mowing my yard in the rain, you know. But if you got to do math, there's way worse things to do than substitution method. All right, so let's do this one. Same pattern. We're following the same exact pattern. The entire bottom of this fraction is going to go away. Okay, so u is equal to 2x cubed plus 7. I'm going to take the derivative of that. So du is equal to 6x squared dx. Now you might ask yourself, I'm going to stop here for a second just to let everybody get caught up, but you might be asking yourself, why do I have a du and a dx and all that stuff? I'm going to do a little aha moment for you. Remember from what we've briefly been talking about and from your Calc 1 classes, remember that dy over dx is really y prime. Let me just move the dx over. Du over dx is u prime. So it is still the derivative. All we're doing, and we're doing it for a reason, we are separating the du and the dx into separate sides of the equation. That is really all we're doing. If I was to be a little bit more careful about what we're really doing is taking the derivative. So that's going to be du over dx is equal to 6x squared. And then I'm just moving that dx over. I'm just preemptively doing it from the start. That's all I'm doing. I'm just preemptively moving that dx over at the very beginning of the problem. And then I'm moving this over so that I get 1 over 6x squared du is equal to dx. Our whole goal of doing this whole take the derivative is to get that dx by itself. That's the entire point of it all. That is all we're trying to do. Okay? That's it. Okay? Because now I can come up here and I can plug everything in and I get 4x squared over u equals, I'm sorry, not equals, times 1 over 6x squared du. Now everything is gone, all the x's are kind of moved over, and I can move everything out front. And so that's going to be 4x squared over 6x squared times the integral of 1 over u du. So I'm using the derivative to make all of that happen. And so this is going to be 2/3 ln of u plus c. Go ahead and plug in my original 2/3 ln, and that's going to be 2x cubed plus 7 plus c. All right. And we're done. We have found the antiderivative of this problem. Any questions about this one? Any questions at all? Any questions at all? All right, so let's go back to this one. This one is the exception. Parentheses overrule everything. So let's write this down. When you have parentheses, that's a horrible parenthesis. Look, parentheses. U is the inside of the parenthesis. and not the whole thing. So that's going to be u equals 4x plus 9. And that means that du is going to be 4 dx. And 1 over 4 du equals dx. So this is the one exception to the rule that I was talking about earlier, is when you have a parenthesis, parentheses overrule everything. And now I'm going to go up here, I'll plug everything in. So this will be the integral of 5 over u cubed times 1 over 4 du. Okay. So the 5 and the 4 are going to come out front. And now I have a situation like what I had at the very, very beginning of this particular lesson, where I had a x squared on the bottom. I'm going to move this to the top, and that's going to be 5 over 4 times the integral of u to the negative third. And then now I can take the power rule, and that's going to be u to the negative second over negative 2 plus c. And so that is going to be negative 5/8 times my original, which is 4x plus 9, to the negative second power plus c. And to finish this off, I'll move this to the bottom. Here is my final answer. All right, so that's what I end up with. Now, I just want to kind of give you guys a thought, a scary thought, but a thought that'll keep you up a little bit. When you're doing science problems, especially physics problems, not so much chemistry or biology or computer science or finance, most real world problems, you only have to do the integral or the antiderivative once because you're starting with the speed, the first derivative. But when it comes to physics and by extension engineering, a lot of times you're starting with the second derivative. You're starting with acceleration. So you have to do 2 integrals. That's just the first one. We would have to take that answer and then find the integral of it, going through substitution rule a complete second time. And that is where people really start to dislike integration. Doing one integral is tough. Doing a second integral based upon your answer to the first integral just steps it up to a whole new level of, well, some words that are not appropriate for me to say right now. But you get the idea. It's going to be a painful process. Okay? And that's where you just have to be patient, take your time, do not get in a rush, double check all of your answers, and just be careful. All right, so that takes care of the second set of notes. So I'm going to stop the recording here, and then I'll come back and do the third set of notes, and that will finish up substitution. All right, so let's stop this.